Hi, I'm Leon, and you're watching Crash Course Environmental Science. What? This isn't Crash Course? Oh, my bad. But this is a review of environmental science. Now, usually there's a rule that our videos cannot go over 6 minutes. However, I think this video is going to have to. Caroline, it is completely up to you if I get punished or not. It's just a warning for this video. This video is a review that I think is fit. I'm an AP student, not an AP grader, so I have no idea what's actually going to be on the test. I was just asked to do a review by some of my friends, and so I decided to do one. That's how much of a nerd I am, that I'm willing to spend my time making a review for a course for 2 friends. So in this expansive topic, what should we start on? Got it, volcanoes. Those are always explosive. I know they're not always explosive, but it was the joke, so come on. Give me a break. When volcanoes erupt, obviously the lava that comes out is very devastating. The ash releases sulfur oxides, which I'll be referring to SOx for the rest of this video, into the air, as well as carbon dioxide. The overspill of lava also starts a primary succession all over again, so that the plants need to regrow out of the igneous rock. Latitude and longitude. Basically, all you need to know here is that as latitude increases, solar intensity decreases. Now let's talk about the atmosphere. Our atmosphere is composed of 78% nitrogen, 21% oxygen, 0.04% carbon, and the rest we don't really care about. The other thing we need to know about the structure of our atmosphere is the troposphere and stratosphere. The troposphere sometimes contains an ozone layer, which is bad for us because it causes respiratory problems. Whereas the ozone in the stratosphere is natural and it's really good for us. It blocks UV so we don't all get skin cancer. Just a quick note that it only blocks 2 types of UV, UVB and C. A still comes through. And just so I don't have to say it later, the composition of the stratospheric ozone is O2 plus O equals O3. Now, the use of CFCs depletes this ozone layer, which obviously results in our skin getting more cancery and other things bad like that. We don't want this to happen. Now, CFCs are involved in the making of styrofoam and refrigerants and aerosols, and obviously the solution here could be to just not use those things. HCFCs are being used now instead of CFCs, which is so much better. I mean, they're still bad. A lot of this is thanks to the Montreal Protocol. Thank you, Canadians, for reducing our CFCs. Now back to the atmosphere after that long tangent on the ozone. Now with weather and climate, a lot of that stuff is very self-explanatory except for the rain shadow effect. The rain shadow effect involves the windward and the leeward side. I'll put a link to the image that I'm going to be describing here because I can't describe well, but imagine like water and then like a hill and then it goes down, you know, and so the side with the water is going to be called the windward side. That's going to have a lot of growth of plants and stuff, and the other side that doesn't have anything, doesn't get any of the water, so that's leeward and it's all dead. The windward side is going to have all the growth and green life because it has a bunch of water from that side, but since the hill is blocking the leeward side is all dead. Now let's talk about ENSO, or El Nino Southern Oscillation. During this time on the western side of South America, the trade winds weaken. This makes the water warmer and causes fish to leave, which hurts their economy. Hurricanes can also happen during this time because the water's warmer, but they're called cyclones down there because it's to the southern hemisphere and they're all wrong. I'm talking to you, Australia. Now let's talk about water. So surface currents in the ocean are caused by 3 things. You've got your prevailing winds, you've got Coriolis effect, which is the spinning of the earth, and then you have your proximity to land, how close that water is to land and bouncing off of it and coming back. 68% of fresh water used is used for agriculture, while less than 10% is used domestically. This means you can feel a little bit less bad about taking an hour-long shower, but I wouldn't recommend it. So water pollution can come in many ways, but one of the biggest is eutrophication is when nitrogen and phosphorus enter the water, usually through fertilizers, and then they cause rapid growth in that area. This rapid growth of organisms stops very quickly, and then they die. Their death results in decomposition, but their decomposition takes away all the oxygen in the area. This leaves a dead zone in the water. Water can also be overdrawn from aquifers, and that results in the salinization of the water. This salinization also occurs very often when we have water diversion, like dams. We'll talk about dams later, don't worry about that. Now we're going to talk about soil, and with soil comes rocks, but I'm not going to talk about those rocks because everyone knows about igneous, sedimentary, and metamorphic rocks. If you don't, link in the description, but I'm not going to discuss it in this video. And just a little tip to some of you, soil always refers to dirt in this exam. Don't let the word soil confuse you. Soil only means dirt. When discussing soil, the big conversation has to be, is it porous or not? How can it hold the water? Like for instance, sand, awful at holding water. It's going to go right through. But other things like clay, it's going to hit it and never going to move. So you've got 5 main soil types. Humus, not hummus. Do not eat it. It is not hummus and it doesn't taste like hummus because all it is decomposed organic matter. You do not want to eat that. Sand, which is high permeability, meaning the water goes right through it. You've got clay, which has low permeability and bad drainage. Silt, which is your kind of in-between of clay and sand. And then you've got loam, which is a combination of all of those, and it's ideal for agriculture. When we talk dirt, not dirty, but dirt. we're going to talk about erosion. Erosion just means there's nothing holding the dirt there, so the dirt kind of just leaves. Imagine the Dust Bowl. Overgrazing of cows on pastures often causes this. Right after big time erosion like that comes desertification, where the land is no longer usable or arable. Slowly, this video is going to go into more and more fun topics, so don't worry. Okay, let's get into the ecosystem. Starting off, we have population and community. The difference is population is one species, while the community is just everything living in the area. Quick review of terms: mutualism, win-win. Commensalism, win for one, it doesn't really matter for the other one. Parasitism, it's win for one and the other one gets hurt. And predation, where one of them wins and the other one lives. Or dies. Depending on your view of life, that will make sense to you. Quick talk about keystone species. They're more important than most species because they have a bigger impact on their environment. Next, edge effect. Different from forest edge, this is when two ecosystems meet and there's great biodiversity. Now let's talk biomes, or biomes. I'm not going to list all the biomes. I will only list the ones that are kind of confusing to people. Tropical rainforest, many people forget that even though it's high productivity, the soil is very low in nutrients. Tundra is a cold methane sink because of permafrost. Think of like a big layer of ice and there's permafrost with methane under it. Temperate rainforest, different from tropical rainforest, it is cold and is used for logging. Aquatic biomes aren't that hard to learn, so I'm not going to put them in the description or in this video. Now to photosynthesis, where plants take CO2 plus H2O plus radiant energy and they make C2H12O6 and they make oxygen. This makes energy and oxygen for us. Cellular respiration basically does the opposite of photosynthesis minus the radiant energy. Like seriously, it's important to remember that plants do it too. Plants do cellular respiration, plants do cellular respiration, plants do cellular respiration. Food web shows where the energy goes. Like I talked about before with biodiversity, it's increased at an ecotone, which is basically the edge effect. Two major climate shifts that this class discusses are El Nino and the Ice Age. We already talked about El Nino, but the Ice Age, well, we've already seen the movie. Like I talked about before with primary succession, it's where nothing has been before or everything was wiped out, like in a volcano, and then something starts growing and then it continues to grow. It takes a really long time. Secondary succession is different, where the area is already ready for animals. It's just different animals come there or plants come there. Carbon sinks are everywhere, so I'm going to list them in a series of jump cuts. Living things, the ocean, sedimentary rocks, fossil fuels, the atmosphere. And another thing about carbon is that carbon dioxide is a greenhouse gas and causes global warming. The nitrogen cycle, everyone's favorite part of this class. Step 1, nitrogen fixation, where N2 is converted into ammonia. Step 2, nitrification, where ammonia is turned into nitrate. Now it gets a little confusing because there's two different branches, but I'll just list one branch and then the next branch and I'll let you know when I'm doing that. Step 3, assimilation, where plants and animals use the nitrate, like in DNA or protein. And step 4, ammonification, where they release the ammonia. On the other side, we have denitrification, where they turn the nitrate back into N2. One more thing about nitrogen though, NOx combined with H2O creates acid rain or photochemical smog. Phosphorus is found in fertilizer and is different from everything else because it doesn't enter the air. Another thing really important about sulfur is that its SOx combined with H2O gives you acid rain. No photochemical smog this time. The companies can use scrubbers when they're doing stuff with fossil fuels to make sure that the SOx stays down. And then you have the conservation of matter, which talks about how matter is never created nor destroyed, just recycled, blah 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 blah. This is gonna get kind of fun soon, I promise. So as far as population goes, you have density independent and density dependent factors. Density independent factors are things that don't have to do with the population size, like natural disasters. Think of tornadoes or hurricanes or tsunamis. While density dependent relies all on the population size, like predation or disease. Then you got your carrying capacity, which is the maximum amount of a population that is allotted in an area. The chart that's going to show you the carrying capacity of a population is going to almost look like an S, where it starts off small, it gets a little bigger, and then it kind of teases off. Then you get your two reproductive strategies. You get your R-type and your K-type. Think R like rapid life. They don't live very long. They have many kids. Think insects. Then you got your K-type, which is what humans are. We live long, we have few kids, that kind of thing. Now there's a graph on the screen that displays type 1, type 2, and type 3 survivalship. I'm not going to describe this because you can see it very easily. Human population. Most important factor when discussing this is women's status. How is the women ranking among men? If a woman is well respected in society and is able to get an education, then their fertility rate is going to be lower because they have less time to actually have kids. Remember demographic transition. Pre-industrial, which is high birth and death rate. Then you have transitional, which is still high birth rate, but the lower death rate. Then you have industrial, which is lowering birth rate and low death rate. And you have post-industrial, where they both equal each other out. Agriculture. Industrial agriculture gives you high yield after high input. Subsistence is kind of just like low yield after low input. It's just to get you to survive. Then you have organic, made with no pesticides, no GMOs, and no synthetic fertilizers. Important reminder that the Green Revolution had nothing to do with GMOs. Do not think about that. What you are thinking about is selective breeding, which is what we've been doing since we first first started using agriculture. Now we're going to talk about pesticides. Insecticides, herbicides, fungicides, and rodicides all do exactly what you think they do. Obviously the benefits are crop protection and disease control. The cons are that it doesn't always work. It also can run off into our water. Some people counter this with IPM, or integrated pest management. This strategy is just to control, not eradicate the pests. Now with forestry, old growth forests have never been used to log trees. And that's the only really important and confusing information. Now for an odd switch to mining. Top countries with oil reserves are in the Middle East. Same for natural gas, while coal is found in China, diamonds in southern Africa, and bauxite in Jamaica. All this falls under the Surface Mining Control and Reclamation Act. This ensures that the land used for mining will be reclaimed afterwards and restored to its original value. As far as fishing goes, trawl net is the one they're probably going to be asking you about. Trawl net is just when they stick a net on the bottom of the water and catch whatever goes into it, often catching organisms that they don't want in there. They might talk about aquaculture, which is agriculture but with water, or the Mason-Stevens Fishing Quota Act. This placed quotas to make sure that the fish wouldn't ever die out. Next is the loss of biodiversity. This can be caused by overuse of land or pollution. It can also be because of introduced species. There are two kinds, exotic and invasive. Invasive go in and they take the place of another organism, while exotic is just kind of there. Here's something that really confuses me even right now. Biomagnification is when one animal in a food chain gets a pollutant in them, and as it goes up the food chain, the amount of the pollutant gets bigger, so it biomagnifies. While bioaccumulation is when it gets into one individual in the food chain, and as it goes up, once it reaches a certain individual, it accumulates high in that individual. Randomly talking about thermodynamics. First law is that energy cannot be created nor destroyed, only transformed. And the second law states that when it is transformed, some energy is lost in heat. Personally, I think this is when it gets fun. I hope the video hasn't been too long yet. The Industrial Revolution greatly increased our energy consumption. It caused a spike in CO2, NOx, and SOx. Just a quick thing about exponential growth. It looks like a J on a graph. That's the current state of humans right now. And right now still, fossil fuels are used for a #1 fuel source. Oil is used the most, but coal is used the most for electricity. So discussing coal, there are 4 different types of coal. Number 1, anthracite. This is the best and most efficient coal. However, there is no more. The second best is bituminous, which is what we use now. Third best, you guessed it, subbituminous. And the absolute worst coal is lignite. You may hear the word peat get thrown around. Don't let it confuse you. Coal is obtained through mining. Oil can be obtained through mining and fracking. And after they get it, they refine it by boiling it to whatever temperature they want. And natural gas is obtained through fracking. Link about fracking in the description. We have about 50 years of oil left, 150 years of natural gas left, and about 200 years of coal left. You might hear stuff about syn fuels, but the problem is with those to be a viable fuel source, it takes a lot of energy to create. This is stuff like methane hydrates found in permafrost. And as far as the permafrost goes, it's a positive feedback. Positive feedback is basically like a snowball effect where the permafrost is melting, which causes methane to be in the air, which causes the air to be hotter, which melts more permafrost. It keeps going. Putting a pro-con list about the fuel sources in this video would take a really long time, so I'm just going to put it in the description, and if you want to read it, you can. Now we talk about the fun stuff like nuclear energy. The process of getting nuclear energy involves splitting atoms, which then makes heat, which then turns water into steam, and that steam turns a turbine. Fuel used is U-235, but a breeder reactor can turn uranium-238 into plutonium-239, which would be used to make nuclear weapons, which is why those are frowned upon. So in addition to a breeder reactor, there are 2 other types of nuclear reactors. Pressurized water reactor has 3 loops, and a boiling water reactor has 2 loops. More on this in the description. Now, nuclear energy is actually really efficient and clean for the environment. I mean, other than the nuclear waste that it produces, it actually is a really good idea, and usually it's kept safe. But in terms of safety, Chernobyl did not do that, and that's why it is the worst nuclear disaster in history. 3 Mile Island occurred in the US, but that was very well contained. After Chernobyl came radiation, and then with that radiation came thyroid cancer. But the nuclear wastes are usually stored in a very safe place, underground and away from people. Fusion is much different from fission. Fusion is when they come together. That's what the sun does, produces more energy. We're still trying to figure out how that exactly works. I said before we'd talk about dams later, and now's the time we're going to talk about dams. Problems you find with dams is the upstream and downstream problems. Upstream you find more diseases because the still water is perfect for insect breeding. But downstream you get thermal pollution. The water gets hotter as it gets downstream. Salmon, being the one fish that doesn't know how to use water, can't get back upstream. But salmon ladders were created, and this is a clean energy source. Dams also cause silting downstream, which is where the water gets cloudy. Now for some energy conservation. So CAFE standards are standards put on cars so that they can have the certain amount of mileage that is required. This makes travel in cars more efficient. And hybrid vehicles use both gas and electric cars now just use electric. While yes, this electricity usually comes from coal plants, those plants are a lot more efficient than a car engine. Mass transit's the other solution, where everyone gets on one thing and that one thing pollutes rather than a bunch of things pollute. Solar energy comes in 2 parts. You have passive and active. Passive is just kind of like a house design thing, like reflective windows or large south-facing windows. While Active is the thing you kind of think of when you think of solar energy, like PV cells and heating your pool. Hydrogen fuel cells, I'm gonna be honest, I'm gonna read notes on this because I still think they're magic. They isolate the hydrogen and split the water across a charged membrane. I'm sorry, but hydrogen fuel cells are not something you should come to me if you need help with. Biomass are just organic materials like wood for heat, or corn or sugarcane for ethanol, or biodiesel from plants. Now we get to talk about wind energy. Big problem with wind turbines is that they're ugly. That's what humans think about. That and they kill birds. And there's like a very minimal area of environmental destruction, but it's like not that big at all compared to the other things. However, there are 0 emissions from this thing, and it's definitely the fastest growing market of clean energy. The small scale hydroelectric is basically dams without the dam. It just produces power from the running water. And I like to think of tidal energy as a wind turbine underwater. Even if that description is wrong, it has gotten me right on tests multiple times. Geothermal energy is basically where we take heat that's trapped in the earth, like steam that's in the earth, and we take it out and we use it for energy or heat. Now let's talk about pollution. So I'm going to use jump cuts to get around all of my major air pollutants. Let's go! NOx, SOx, carbon oxides, not gonna say that. VOCs, O3 or the ozone, lead, mercury, and photochemical smog. It's important to remember that photochemical smog is different from normal smog. Normal smog is caused by SOx, and that's found in places like London. But photochemical smog is formed with sunlight, NOx, and VOCs, and that's found in LA. Acid decomposition is caused by acid rain, and it causes forest decline, thin-shelled eggs on birds, and it erodes statues. Reminder, acid rain does not harm humans on the skin. Time to learn about indoor air pollution in jump cuts! Radon, the coolest sounding of all of them, causes lung cancer in well-insulated homes. Carbon monoxide, you get this from cars and it slowly suffocates you. Formaldehyde, found in new carpets and it is in fact a carcinogen. VOCs, they come from fumes from everything in your home. They cause headaches. Cigarette smoke, I think we all know what this stuff does. Mold and mildew, which is a respiratory irritant. Sick building syndrome, where the building is not sick, you are. Now, out of all the air pollutants I said before, the EPA set limits on these with the Clean Air Act of 1970. And the Kyoto Protocol sought to reduce greenhouse gases, but the US didn't sign it because we're no fun. Noise pollution basically disrupts animals from finding their mates. That's the major environmental consequence. But since humans always like to have a reason to hate something, it also hurts our hearing after a while. Solutions to this are usually just barriers or time limits on when you can drive a car. Point sources versus non-point sources. Point sources is a single source creating the pollution. Non-point are multiple sources creating the pollution. Jump cutting through the water quality tests. Let's go. Test for nitrates, phosphorus, the pH, turbidity, fecal coliform test, dissolved oxygen, smell, BOD, and benthic macroinvertebrate larvae. Since you're all sitting there thinking, what are those? Or you're sleeping, it's basically like a mayfly thing. It's an indicator species. To purify the water, there are 3 steps: coagulation, sedimentation, fermentation, and disinfection. Sewage treatment steps. Primary treatment, where suspended particles now settle at the bottom. Secondary treatment, where you disinfect it using microorganisms. And an optional tertiary, where you send it out into like a swamp type thing to remove any phosphorus or nitrogen. Big thing here is the Resource Conservation and Recovery Act. You'll probably see it as cradle to grave. Basically makes sure that the hazardous materials are taken care of from their birth until their death. Now we get into solid waste. Municipal waste is basically home waste, like things that citizens are using. While non-municipal waste is things industry is using or agriculture. 3 ways of disposing of these wastes: recycling, sanitary landfills, or incineration. The problem with sanitary landfills is, well, they fill up, and when they're released, they don't decompose all the way, so they release methane. And recycling only works on certain products, and other things it's not economically sensible. Incineration just releases bad things into the air instead of it sitting on the ground. So, human health. Some of you may notice that the lighting just changed. Well, that's because it took 2 days to film this. So next is environmental risk analysis, which is 3 steps. Step 1, risk analysis. You identify what the hazard is and the extent of the exposure. Step 2, risk acceptance, where you determine the acceptable levels of the risk. And step 3, risk management, you determine the policy. Diseases acute and chronic. Acute diseases aren't necessarily small diseases, but they're more of they happen in a short frame of time, like Ebola. Whereas chronic is more of a long-term thing, like heart disease, AIDS, or cancer. Dose response. Your LD50 or your lethal dose is your dose that kills about half the population, while the threshold is the amount that kills your first subject. Types of hazardous wastes in jump cuts. CFCs, we already talked about these. Radioactive waste, this usually comes from nuclear plants. Acids, coming from fossil fuels like sulfuric acid or nitric acid. Lead, most commonly from e-waste or electronic waste. And mercury, which is also from e-waste and causes neurological damage. Now to get rid of these wastes, we have 2 options. Option A, hazardous waste landfills. They're stored until they're not radioactive anymore. more. This can take thousands of years. Or option B, incineration, where we just burn it. Cost-benefit analysis. This looks at social benefits versus the amount of money that it's going to take to make changes to get those social benefits. This does not take into account externalities or effects on the environment. And the fun topic of global warming we saved to the end. You've been waiting this whole time to hear about global warming. Well, now you're going to get to hear it after a long time. Listing of greenhouse gases in jump cuts. CO2, methane, nitrous oxide, CFCs, and funny enough, H2O. The buildup of these chemicals all cause the greenhouse effect, which warms the earth. The temperature's rising, our seas are going to get hotter, which is going to cause more powerful hurricanes and more mosquitoes. Not to mention the polar bears you're killing right now. Coca-Cola is going to have to find a different mascot. How can we reduce this? Use solar panels, hybrids, hydroelectric power, mass transit, plant frickin' trees, stop consuming beef. I'm not gonna do this, I'm just listening. It is! We did it! We made it through the whole freaking class. I mean, I left out a bit, but we still did it! We did it! Good job! I hope every single one of you passes your exam, and selfishly, I hope I pass my exam. I seriously can't believe you made it to the end of the video. And to prove it, you should type dinosaur in the comments, so I know that you specifically made it to the end. It's kind of ironic I'm wearing this shirt when I'm talking about fossil fuels, right?